Here there is an infinite network of two capacitors, 1 microfarad and 2 microfarad, repeated in a particular fashion. 1, then 2, 1, then 2. There's a rhythm for this arrangement of the capacitors. It don't stop here. This is continuing till infinity. It don't end. We're asking the equivalent capacitance between A and B. So since it's infinite network, we cannot directly apply any series parallel combination. First, let's assume the total capacitance of the entire infinite network to be C. If it's a resistor, it will be R. So let the total capacitance of the entire infinite network to be equal to C. Now, since it is an infinite network, adding one set of repeated group of capacitors or removing one set of repeated capacitors will not affect the entire capacitance because it's an infinite network. So keeping that concept in mind, we are trying to remove one set of 1 microfarad and 2 microfarad so that the rest of the capacitors all till infinite will have again the same capacitance C. So we are separating this one set of 1 microfarad and 2 microfarad. Since we only separated one set, still there are infinite number of capacitors. This red color part till infinity again will have capacitance C. So this is the way you approach infinite network. Let's assume the total capacitance without changing any of the given factors BC. Then see the repetition 1, 2, 1, 2 repetition. So remove one set of repetition. Since it's an infinite network, the rest of the capacitors till infinity will have again the same capacitance. So this full red color portion can be replaced by again with a capacitor whose capacitance is equal to C. The equivalent of all this is same as the entire network, so we can replace this by C. So 1 microfarad, 2 microfarad, and between these removed points, the total capacitance can be C. So that removed part is again C. We removed 1, 2, the rest will be infinity. That full network of capacitors can be replaced by a single capacitance, which will be again equal to C, even you remove one set of repeated capacitors. That's a concept. So now these two capacitors, 2 and C, are in series. That we can replace by a single capacitor, which will be parallel to 1 microfarad. So this parallel combination will be 2 into C by 2 plus C. Now these two are parallel. So C parallel plus 1 microfarad will be equal to again C only, because we assume total capacitance to be C. The total capacitance C will be equal to 1 parallel with CP. CP will be 2C by 2 plus C. Now we got an equation. To solve this, multiply all the terms with 2 plus C. So 2 plus C into C equal to 1 into 2 plus C, which will be 2 plus C. 2 into C by 2 plus C into 2 plus C. So 2 plus C get cancelled. It will be just 2 into C. So C into 2 plus C. 1 into 2 plus C will be just 2 plus C. 2C by 2 plus C into 2 plus C. 2 plus C get cancelled, just 2C. So opening the bracket, 2C plus C square equal to 2 plus 3C. Now, this will be a quadratic equation, transferring all the terms to the left side, c square. This will be minus 3 on the left side, minus c plus 2c will be minus c, 2 will go minus 2. So c square minus c minus 2 equal to 0. Now, this is a quadratic equation. The product should be minus 2. The sum should be minus 1. So the numbers will be minus 2 and plus 1. Minus 2 into 1 will be minus 2. Minus 2 plus 1 will be minus 1. So you can split the middle term and group c minus 2 into c plus 1 equal to 0. So c minus 2 equal to 0, that will be c equal to 2. C plus 1 equal to 0, that means c equal to minus 1. Since capacitance is not possible with minus 1, we are neglecting that possibility. So capacitance C, the effective combination has to be 2 microfarad. The basic rule is, again, I'm repeating, let the entire capacitor be C without any change for the infinite network. Since it's an infinite network, even you remove this 2 and 1, the rest infinite will be again have the capacitance C. So this C will be same as 1 and 2 along with the entire network again becoming C. From here you can apply the normal series combination. That result will be parallel to this, that will be again equal to C. That's a basic rule in the method of solving of infinite network of capacitors.